hear and see me okay?
Yes. Yeah, I can see it here.
Yeah, I might end up turning my camera off depending on how the situation works out.
Oh, your mic's hard to hear.
It should be okay. Talk a little bit about different file types and especially one of my favorite types, CSVs. But let's back up a little bit and talk about what exactly a CSV is. So CSVs, break the name down, turns out that comma separated values. And here's an actual example of a CSV file. This is an example that we're going to be using today. And as you can see, it is literally just a bunch of columns separated or delimited, if you want to use a fancier word, by commas. So at the top here, we have the headers of the file, which is just like a random file that I've got on my computer. It's like the site ID, the state ID, remark element name, remark, and then you've got a bunch of rows. And at first, this looked like a really, really giant jumble of stuff that can be very difficult to interpret. Moreover, if we go to a file that's even larger, like let's say this one, this is pretty much illegible to any human, which isn't great. So today we're going to be talking about how to make it slightly more legible and interpretable, and also how to manipulate them, which is really fun. So an easy way to break down a CSV file is by simply putting it into something like Excel or Google Sheets. And this is, okay.
It's okay. I mean, yeah, there's only so much you can do, but yeah. So the audio's not great, but it should be okay.
All right, let's see if this is any better. Maybe. If not, that's all right.
Yeah, it's a little louder now. Yeah.
Okay, awesome. So this is an example of that exact same CSV file that we just saw like 30 seconds ago, but put in a nicer format via Excel. So Excel can read in CSV files, which is a very lovely thing about it, and it puts them very nicely into columns. So you've got your site IDs all nice and lined up here, your state IDs as well, and again, it makes it a whole lot more legible. So today what we're going to be doing is figuring out how to do the exact same thing, but in Python. So going back to VS Code, I've created a file here that I just called bigfilerate.py. We can disregard the file names part for now and go right over to, actually, let's talk about what I've got up here. So I've got a couple of import statements, first of all, which we're going to need because we're not going to be using the default CSV reader functions today. We're going to be using one of my favorite modules in Python, which is called Pandas. And I know Sam and I talked to a couple of you guys about it yesterday and a few days ago, but for the uninitiated, Pandas is essentially the wonder library, or one of the wonder libraries of Python. It can be used for literally anything that you want to do for data analysis. If you want to take a bunch of data from a bunch of file types, which is something we'll discuss momentarily, and turn that into Python readable objects, you can do that. If you want to manipulate a bunch of really large or really small data sets, you can do that. Basically, Pandas makes your life a whole lot simpler when it comes to data analysis. And I'm quite sure that come personal or group project time, a few of you guys will end up needing to use this as well. So it's always a good idea to get started using it now, especially for simple use cases like this. So normally when you're opening up a CSV file in Python, you have to do like the with file name as open and the for loop, iterate through each row. Pandas makes it way simpler. You just go on line 14, as you can see here, we have a command called PD is the name of the library that I've abbreviated to, and you can just use the read CSV function. That's it. There's nothing more to it. This will automatically dump the contents of your CSV into something that's kind of like a two-dimensional list, but not, and that's called a Pandas data frame, and we'll explore that more in a second. So here I've just put in the file name, which I'm calling all remarks data.csv. And I also have another thing in here, which is low memory equals false. So CSV files are great for small applications like the ones that Chad was demonstrating earlier, but the real power of CSVs and Pandas really kicks into gear once you deal with giant data sets. And that's why, at least for me, whenever I import things through Pandas, I usually try to keep the low memory equals false in, because that helps to speed up the runtime a little bit more, and also just helps you get more data in there. So let's see what sorts of things we can do with our new data set. So the first thing I'm going to do is print out the data frame size. And the size is how many elements are contained in there. And if we wait a second, you can see in the terminal that we have 368,488 elements, which is pretty big. So again, this is exactly what a great use case for when CSVs are super helpful. If you have like tons and tons of data, this is a whole lot better than a lot of other data types, and we'll see why in a little bit as well. So the next thing that Pandas lets us do is get the shape of the data frame. And the shape is basically the dimensions. So if we go down here, so we can see that we have 92,000 rows and 4 columns. And if we go back to our nice Excel sheet, we can definitely see the 4 columns make sense because of the 4 bullet things at the top. And I'm not going to scroll all the way down, but 92,000 is probably about right for the number of rows. Okay, so now that we have the dimensions of this giant data frame, let's see if we can actually unlock it and look at what's inside. So again, normally you'd have to do 4 row in rows with the file open. Here, you just need to read the CSV and you can take as many rows of it as you want. So what we're gonna do is we're gonna get the first 10 rows. And you can do that by using the head command. So the head is basically the first rows. And if you wanna get the last rows, you can use the .tail command. But for our purposes right now, let's just use .head and get the first 10. A little bit. All right, so here again, we can see it's a little bit more nicely formatted than the raw CSV file text, which is right here. But you can see that, we've got all our IDs, we've got our full header up there. Everything is nicely column formatted, unlike over here. And crucially, this is similar to an array in that we have indices on the left, which is the 0 through 9. So we're going to get to how to use those in a minute. But basically, Pandas really helps you break down your CSVs into a more human readable format and also just easier to manipulate as well. All right, so the next thing that we're going to do is just get some general information about the data frame, which we're going to do through this df.info command. And also, Pandas has a ton of really awesome documentation that you can look up to if you want more details on any of these commands. It will also be a lifesaver once you start using Pandas for real in your programming projects. Let's see what happens when we get some information about the data frame. All right. So the first thing that it says is that this is a Pandas data frame with the class. We've got a range index, which is the indices. It says there's 92,000 entries. Now we've got the indices going from 0 to 92,121. And we've got 4 columns, which are the 4 listed here. Now there are a couple of things that are interesting that we want to take note of. Number 1 is the DType. So the DType is the data type of the column. And here, as you'll see, it says object, which is good because it means each column is an object. What type of object? We don't know yet. That could be because of the null values. So here, the non-null count is also extremely important. And what we'd always like to do is make sure that whenever possible, that the number of non-null values is the same as the number of total rows. Because if they're not the same, that means that we do have null values in that column, and null values are essentially values that can't be used. It may be the data in the original CSV was bad, or maybe there just was no data. It's like for some of these, maybe they just didn't have a state associated with them. And generally, we want to try to get rid of those whenever possible. The other thing that's important to keep in mind is the memory usage. So this is not very important at this stage, but it'll become very important later on. But as you start dealing with bigger and bigger data sets, they start taking up more and more memory space. So trying to double check that the amount of memory that you're using isn't a super obscene number is always good. And if it is, extremely large, let's say a gigabyte or something, then you'll have to optimize your algorithm to break the data down into smaller chunks or store it more effectively or something like that. All right, so before I move on to doing things with the data frame, does anybody have any questions?
Nope, following right along.
All righty, so let's move on to actually doing stuff with the data frame. So normally in Python, if you want to access a row or a value in a list, you just do like list and then square bracket, the index and closing square bracket. In Pandas, it's a little bit more complicated. So if we go back to this guy, and I'm going to uncomment that. Let's run this again. Run. All right, so if we take a look at the data frame one more time, you can see that there are multiple ways that we can access a column. The first way is the quote unquote easy normal way, which is to access a row by its index, which is listed on the left, the 0 to 9. The second way we can do, which is a little bit more complicated, I'm going to show you guys how in a couple seconds. The second way is that we can access a row based on a column value. But let's do the easy one first. So the first thing that we're going to do is we're going to do df.ilock of 5. And here the I basically stands for index. So we're going to get the row with index 5. So if all goes well, this should print out this row down here. But let's double check that it actually does that. And again, it'll do this in a bit of a weird format. It's not as nicely tablified as the one above. But if you take a look, it actually kind of flips it around and makes it like columns, which is kind of interesting. So we can just cross-check the values in here. We've got the 4C, DCTC, blah, blah, blah. And that lines up with number 5, which is what we're looking for here. So that's how you get the nth row. Basically, if you want to get the nth row, you just do a df.iloc or index location, and then you put the number that you wanted. But now, as you've noticed, this format is kind of messy. So instead, what we can do is we can convert this to a format that you all have used a couple of times by now, which is a Python dictionary. So let's see what happens if we do that. All right, there we go. So this is something that is a lot simpler to manipulate in Python. And we've got a dictionary for row 5. So as you can see, it's if you go for the key site ID, the value is going to be 00106. $A, for the remark element name, you can do the same thing. And this is something that, if you wanted to get a nice specific value out from this, you can definitely do. So normally it's in Python or Pandas, you can convert a row of your data frame to a dictionary or to a string, to like a list sometimes, or a NumPy array. There are a lot of functions, but just for right now, we're going to stick with the 2 dictionary. But again, there are lots of others that I definitely invite you guys to check out on your own time. All right, so that's the first way that we can do things. The second way, as mentioned, is if we, again, there we go. The second way that we can access a row is instead of going by index, what happens if we go by, say, the state ID or the remark element name or the site ID? Because again, these are all valid columns. So technically, we should be able to go and pick out a row based on that. And that's exactly what we're going to do now. So you'll notice the difference between the command on line 27 and the command on line 23 is that on line 23, we're using iloc or index location. But on 27, we're just using lock or normal location. And here's why. So what this command does is it's going to give us the row or rows whose site ID is going to be the 00103.A. And the way we do that is we can't just do dflock site ID or dflock 00103. We have to basically say, hey, I want you to give me the location of every single row whose site ID equals blah. And let's just double check again that this works. I'm going to comment out the head part because that's going to take up a lot of space on our screen. Let's see. All right, so we've got, here it says 4 rows. And if we go back up to our previous thing, we can see that the first 4 rows all have that same site ID. So it looks like it works. And do we see anything that doesn't have that site ID in it? No. So basically df.lock gets you the rows with a given column value, while df.iloc gets you the row at a specific index. And from here, we can also do something that I find extremely magical, which is, again, sort of like if you had a 2D list or 2D array in Python, you can get the value at that row and column. Well, in Pandas, we can do the exact same thing. So what we're doing now is we're going to first get all the rows whose site ID is going to be this on line 28. So that's going to be this first one. But next, we are only going to get the first row with the given site ID, which is why we have the iloc 0. And then we want to get the remark of that row, which is listed over here. So here, let me uncomment that line and run this again, just to demonstrate for you that this works. So right, these are, again, all 4 of the rows that we have that have the given site ID. Next thing we're going to do is we're going to get the first row using that iloc command, which is this one. And then we're going to get the remark, which is going to be this 4CD CTC Karen's approach. And that's exactly what's listed down here. So if you want to get a value in a value of a row in a data frame, generally you want to use a loc.iloc, or if there's only one result in the data frame, you can just do an loc and then whichever column you want to use. So sometimes, again, it can be a little bit confusing, especially if it's your first time using Pandas, but generally the examples in the documentation are really fantastic, and they go into a lot more use and edge cases, so I'd highly recommend checking those out as well. All right, so before we move on to a couple other features, does anybody have any other questions, or are we mostly okay for now? All right, I'm going to assume no questions, but if anybody does have any, please feel free to speak up or pop it in the chat, which I've got open as well. All right, so there are a couple other cool features of Pandas that we can use, and then after that, we'll move on to some different data types. So the first thing we can do with Pandas, and again, it's all using the Pandas internal data frame structure. So the first thing that we can do is let's go back up to, let's see, is this still here? Keep going. Yes, all right, let's go back to this guy. So if we take a look at the DType, again, remember, DType is the data type of the column. All of these are objects. An object is super generic. It could mean that it's an integer, a string, a null type, who knows, which is, a bit of a problem. So instead, what we can do is we can convert a given column, rather, not row, column, to whatever type you want. So using this command, for example, we're going to convert all the site IDs, or the entire site ID column, into a string. And you can do this for strings, for integers, for floats, for tuples, for pretty much anything. And all this command does is it basically goes item by item through the column site ID, and it says, for each thing in the site ID, I'm going to convert that site ID from an object to a string. That can be very useful for data manipulation later on. Another thing that we can do, going back to something we talked about around 10 minutes ago, is remove those very pesky null or NA values. So if we take a look at that state ID area, it says, that there's a different number here for the number of non-nulls versus for site ID or remark element name, which means that state ID does have a bunch of null values. So let's see if we can get rid of those real quick. So if I run this command, it should drop all the rows with our bad/null values. And let's double check down here that that's correct. So we take a look again at, this is the shape of the original data frame. It has 92,000 rows roughly. The new one has closer to 91,000. So it dropped probably about 400 to 500 rows. All of those had a null value in them, which is pretty significant. You don't have to drop null values. You can also replace them with something else. So for example, if you want to keep those rows but replace the null value with like a 0 or a negative number or a string or a Boolean, you can always do that as well. But generally, if you have super big data sets that only have a couple of rows that have null values, it's better to just drop them. Or you can turn those into the means, but that's something different. Again, you can find out more about this in the Pandas documentation as well. All right, so there's one or two more cool features that I want to talk about for Pandas with CSVs, and then we're going to talk about how to deal with different types of data as well. So the first thing that we're going to do is learn how to create a new data frame. So there's one way to do this, that is create a data frame from an old data frame, which is doing like the new df2 equals df.head, or again, the top 5. The second thing that we can do is we can type in pd, or we'll just say like new df equals pd dot data frame. And then in here, you have to put in some sort of data and indices. So that would basically be like a dictionary or a list, and the index is something similar there as well. And we'll talk a bit more about that in the next few steps. So here we can print the new data frame if we want to. It's not needed at this point. And then down here in dict1, comment that real quick. There we go. So dict1 is, again, an example of a dictionary that follows the format of the columns. And this is extremely important for pandas because you're basically, what we're going to do next is just like you would with a list, you can append a dictionary to the bottom of this pandas array or this pandas data frame. So here we've got like a site ID of 1, 2, 3, 4, state ID of AB, which doesn't exist, mark element name for something else, and a remark of like hello, for example. So let's go ahead and just see what this does really quick. So we're going to print out the original data frame, new data frame 2, which is just going to have 5 things in it. And then this one should have 6. And let's see what happens once we run this. So here, let's stop here. Oh, that is not what I wanted to do. Let's try that again. Nope. Okay. Well, anyway, the top part that I've highlighted is the original data frame. And the part down here at the bottom is the new data frame. And you can see that these two are exactly identical, except for the fact that the new data frame has a row with index 5, while the old one doesn't. And that has everything in our dictionary in it, which is fantastic. So that's one way that you can add new data to a data frame. The second thing that we can do is concatenate two data frames. So that concatenation basically just means combine them. So what we're going to do here is we're going to combine data frame 2, which is the 1, 6, with the last 5 rows of our really old giant data frame. And we can print, see what happens when we do this. 2. And let's see. All right, so if we run this, as you can see, we have 10 rows, or 11 rows rather. We've got everything in new data frame 2, which is the top 6 rows. Let's see, can I select these? Yes, the top 6 rows. And then these last ones are just 5 rows from the tail of the original data frame. So that's how you can combine 2 data frames into
I think we lost them.
Okay, I think my connection dropped for a second, but can you guys hear me okay?
Yeah, I can hear you now.
Okay, that was really weird. Where did you guys, or where did I lose you guys?
No, it was just a second.
Yeah.
Okay, cool. So, all right, so the last thing that we're going to do for right now, then I'll take a short break for questions, is we can take our data frame, remember this is a Python pandas object, and which we imported from a CSV, and we can spit it back out into CSV form as well. And the way you do this is you basically take the data frame, you type this toCSV command, which you can convert it into a CSV. You type the file name that you want to use. I'm going to call it testing.csv. And if we run this real quick, now put some stuff in the terminal. Down here, you can see we've got our new file. And if we click it, we've got a brand new CSV right here. And this has, it's got this columns that we want. It's got our last row that we appended. It's only got the number of rows that we need. And you can take this CSV that we just generated. You can open it up in Excel. You can open it up in Python, in JavaScript, and anything that you want. It's a CSV to use for all of your purposes. And that is the gist of how to manipulate data in Pandas. So before we move on to part 2, which will, I promise, go a little bit faster, do you guys have any questions about Pandas for now?
I have a question.
Go for it.
How do you get a big chunk, like a big chunk that you would want, say, for example, you want rows 2 through 10, columns 3 through 4. So I guess like slicing into that data frame.
Sure, that is a good question. So that is something that you'd want to do in this like read dots. So there are 2 ways to do that actually. The first way to do it is in the read.csv. So the first thing that you can do is do that directly in the pd.read CSV. And you can add some parameters in here. Again, the documentation will have more specifics on that. But you can basically state which rows, if you want to like skip a number of rows, I think you can do like rows equals, and you can skip, say like you want to skip the first 3 rows, it'll skip those. And you can also specifically state which columns you want to extract from the data set in there as well. So that's the easiest way to do it. Now, the other way you can do it is once you've created your data frame, you can create a new data frame and basically just use, again, the LOC and ILOC commands that we talked about earlier in order to splice the data frame or extract a chunk from it, just by saying which columns you want it to use and which rows you want it to use. And you should be good after you do that.
Okay, thank you.
Yep, no problem. Any other questions?
If you scroll down, I missed what one of the arguments meant all the way to the bottom.
All right, which one? All right, like hereish?
Ignore index equal true.
Question. So ignore index equals true. Here, let me actually try something real quick. Comment that so I can show you exactly what I mean. Go down to the bottom. Sure. All right. So right now, what you can see down here. Oh, I forgot to print. That's one. All right, so right now you can see that the indices go nicely from 0 to 5. And that's because we have ignore index equals true. Ignore index basically means that you're going to append to our data frame, but we're not going to take the indices of whatever we're appending to it. So if the indices for what we were appending to it were like 10, 11, 12, 13, and if we didn't have ignore index on, then we would have 0, 1, 2, 3, 4, 10, 11, 13, 14. Which, you know, it doesn't make very much sense logically to do that, because again, that's just Panda's way of saying, I'm going to take the easy way out and just smush these 2 data frames together. But if you do ignore index, it'll actually, again, and we can see this more clearly with the new data frame 3, that, where we've got, again, 6, 7, 8, 9, 10, it lines up more logically and follows from the original indices here. If we had ignore index equals false, and we rewrote the code just a little bit, then these indices down here would all be the original indices of these rows, which would be like 92,000 something, something, something. Does that make sense?
Yeah, thanks.
Alrighty, no problem. Any other questions before we move on to part 2?
One more question. Can I see your imports at the top?
Move on. So now that we've talked about how to read stuff from Pandas and in Python, there are a bunch of different data types.
Sorry, Omar. Would you mind just showing your imports one more time at the top?
Sure. So yeah, the only thing you really need is the import pandas as PD. All these other ones are for the second part of the presentation. That'll be specifically about how to do it more efficiently. But yeah, there's very few, if any, imports needed. And for pandas, all you really need to do is just pip install it in your virtual environment or to your computer.
Cool, thanks.
Yep. All right, so part 2 is going to move a little bit faster now that you guys know the basics of doing stuff in general with pandas. And it's going to be about how to do things with different data types. So let's go back to my Excel sheet over here. Excel, there we go. So I've got an Excel sheet with 4 very, very large data sets. This has like over 100 columns and like easily thousands of rows. Same thing for this one. This one, the third one we just looked at, and the fourth one is also pretty long. Now, these easily have like millions of data points in them, and I want to import them all into Python so that way I can do stuff with it and create pretty graphs. How do I do this? So, okay, well, the easiest thing we can do is say, hey, I've already got everything in Excel. Let me close out of this Excel sheet, actually. There we go. We've got everything in Excel, so why not just import from an Excel file into Pandas? And that would be great, except for the fact that this takes a pretty long time. So I've run all this code beforehand. I'll be running it shortly as well, but not all of it, but some part. Excel file with millions of rows from the local storage, meaning from my computer. This would take nearly an entire minute, which seems pretty short, but compared to how quickly we can do it with some of the other file types, you guys will definitely be surprised. And this is the general way that you want to read from an Excel file. So you'll basically go for sheet in sheet files, which is the number of sheets you have, then the start, and then I've just timed it using the start time and timed@time. Python's timing library is very useful. I would encourage you guys to use that, especially when you're trying to speed up your algorithms. And then just like we had pd.readcsv, we've also got a read Excel file. And you just put the Excel file name, and then the other thing that you have here is sheet name. So if we go in Excel, obviously you can name your sheets, and using the sheet name, you can tell it which sheet you want to extract from, because unfortunately you can't read from all the sheets at once. You have to literally go sheet by sheet. And this takes about a minute total, which is not great. So the second option that we have is, instead of reading it from Excel, we can take each of the sheets and export each sheet into a CSV file. So here we've got this XLSX file, and I've exported each sheet from that into a different CSV. So you've got this airport data CSV, remarks data, runway data, scheduled data. And compared to reading the entire Excel file, if we just read the individual CSV files from it, it takes about 1 second to read everything. So that's already a pretty big speed up, going from a giant Excel file to a CSV to 4 CSV files with the exact same data. So lesson number 1, whenever possible, use CSV files instead of Excel, because sure, Excel files look prettier, but CSV files are a whole lot more efficient for programmers. And again, we can just use the pd.readcsv and put in low memory equals false if you like, and that's about it. The second data type that we're going to talk about is JSON, which is extremely common in data science and also in web programming, as we'll see once we get a little bit closer. And JSON stands for, as written on the screen, JavaScript Object Notation. So this is a really common data type whenever you have a large amount of data that you can store nicely in dictionaries. And again, I'm sure that we'll go into more details on this once we get into the web development unit. But it basically will take everything from your Excel file and put it into a dictionary. So let's see if we can open this up. Perfect. So for example, here, it takes all the site IDs and turns them into a really dictionary. And it'll do the same thing for everything else. So a little bit cumbersome to work with. But again, Pandas makes it really easy. And this is one of the most well-known file types out there for big data sets. So the first thing that we need to do is convert the CSV files to JSON. And there's a relatively easy way to do this. Again, this is all using Pandas, which is why I love Pandas. Now, the first thing that we can do is we can read each of the CSV files and convert those CSV files into Pandas data frames, which is exactly what we did way back in the beginning. But next, we can use the JSON format in order to convert those data frames back to JSONs. So essentially, what we're doing here is we're going CSV to Pandas data frame to JSON. And this is a pretty standard way of converting files in Python. You'll usually want to convert it to a Python internal object file type, or internal object type, like a data frame or a list or dictionary. And then from there, convert that to your other data type, like JSON. And generally, conversion takes a couple of seconds. Again, since we have such big data sets, but for smaller data sets, it's pretty quick. And then lastly, we can also read the JSON files from local storage in Python again. And we can do that using this pd. You guessed it, read JSON. So whenever you want to read a file from local storage or from anywhere using Pandas, pretty much just need to use the read blank function. And if you want to ever convert something from a Pandas data frame to another file type, you just need to use the to and then that file type notation. And there are more caveats that go along with each of those. There are different ways to convert them. You can read in different file types and so on. Again, documentation has a lot more details on that, and there are a plethora of file types you can use. But for now, we're just going to be covering the most common ones. So again, going back to the beginning here, reading the blank Excel file from local storage took about a minute, which is very exhaustive, while reading JSON files takes about 2.5 seconds, which isn't too bad. Now, the last file type that we're going to talk about today is pickle files, which is something that probably most of you guys haven't heard of, and I hadn't heard of either until somewhat recently. And a pickle file is essentially a data type specific to Python. Now, you might be asking, okay, why is this in any way useful? Surely Python already has stuff built into it, like data frames and arrays that we can use. Why do we use pickle files? And here is the answer. A pickle file is basically a way for Python to store Python objects in it. So, for example, like let's say you wanted to send a class or 15 instances of a specific class to your friend via email, but you don't want to send them the code, you just want to send them the class instances. So one way you could do that is convert the classes into a data frame and send them the data frame, but that would be pretty yucky. The second way we can do it is by serializing those classes using a pickle file, turning those classes into a .pkl file, which you can see on the right, sending them that .pkl file, they open it, and then they get all the information of those classes instantly. That's why PKL files are super useful. They're also pretty compressed, which is good in terms of storage, but CSVs are generally better than those in terms of storage. However, we'll see why pickle files are so helpful in just a moment. So reading pickle files from your local storage, again, these are giant files with millions of data sets or millions of data points and like hundreds of columns. It takes less than half a second to read 4 of these gigantic files. And if we can compare that again to Excel files taking over a minute to do the exact same thing. So again, Python and Pandas have many methods to deal with a numerous amount of file types, but depending on your application and your specific code that you're writing, you're going to want to use the different file types and different export and import different data types in order to get the fastest and most accurate results. And Pandas can help you with that. And that's all I've got for now. Thank you guys so much for listening.
All right, thanks very much, Omar. Cool, awesome. Yeah, Pandas is a very useful library. It does, yeah. I mean, as Omar showed, it does all kinds of cool stuff. So if you end up doing any kind of data analysis, you'll almost certainly be using Pandas. And if you do anything like, machine learning, anything like that, even if you don't use it directly, those libraries are almost certainly using Pandas as well. All right.